So this is a project that I've been working on with Valeria for the last for a long time, and also with Stefania a little bit. And so kind of the goal is to, I guess, bring informal kind of information about formal concepts like regular math resources to kind of bring them into conversation with formal resources. So it's a cross-resource glossary of undergraduate level, for the most part, mathematics, and providing kind of like links between concepts that appear in 5 different bodies of math knowledge. So here's kind of like a picture of what MathGloss looks like, which I have over here, right? You can click on things, go to where they are, you know, pull up, oh, now I know all about finite abelian groups. And there's some like little problems with it, right, of course, because finite abelian groups are not exactly the same as abelian groups. But we'll talk about like kind of why this is happening in a couple slides. Or I guess the last one to look at would be like the lean links. So this takes you to kind of the MathLib place where you can learn all about or use the transpose of a linear map. So the 5 corpora, we saw some of them. Wikidata is the first one. It kind of provides the backbone of MathGloss, right? We use this to, I guess, in some ways ensure that the concepts are the same, that when we're like linking them across the rows in the table. So Wikidata has, you know, a unique identifier that starts with a Q and ends with a long number for hopefully every concept in the world, I guess, is their goal. It has some semantic information stored in it. Like I think we saw, or we'll see examples in a minute, but some of it's pretty useful for mathematicians. Like it tells you, oh, like a group is a subclass of a monoid, and other things like that. But some of it's not terribly useful because it includes like a picture of a Rubik's Cube for some reason. The next corpus is the Chicago one, which is kind of a collection of atomized definitions. So kind of being as, you know, each little thing gets its own definition of concepts that I encountered during my undergraduate degree. So the MathLib undergrad corpus is links to math concepts in MathLib. So there was a list on the MathLib website that kind of shows, you know, the undergraduate level concepts that exist in MathLib. I think that list is somewhat incomplete. There's some things that are not like mapped, shall we say. They may be formalized, but they're not like said, oh, this is the concept and this is where it is. So this is kind of like an attempt to, in some ways, make that happen more. So Mulima is a list of translations of math terms between natural languages. And so these terms have manually checked mappings to Wikidata, and this was made by Tim Osgood and several collaborators. And then finally, the last corpus is the NLab. So this is like links to articles about math concepts, like the undergraduate level math concepts as they appear in the NLab for somewhat of a more categorical point of view. So here's the examples, right? So this is the group page in Wikidata, right? It gives you a basic definition at the top, which is sometimes pretty good. In the case of the group, it's a reasonable definition, but you know, for some, I guess, more obscure math concepts, they don't exist at all. And then there's a few synonyms over there. And then there's the statements, right, which are the semantic information that exists in Wikidata. A group is a subclass of a monoid. There's a bunch of other ones. It's a subclass of algebraic structure, like Mu-Fang loop. There's a bunch of different things that it, you know, says about. But again, it's not complete information. Some of it is like a picture of a Rubik's Cube, which is not useful. Here's again the definition from the Chicago notes for the group, right? This is just something that I kind of, you know, wrote as I was studying for exams, learning math in classes, and then here's the, you know, MathLib entry for group. Looks somewhat similar, but again, it's you know, in lean. And then finally, or not finally, here's the Mulima one. So this is again showing you the translations between English, Farsi, and French. When you search for group, you get all these kinds of different instances of it. In French, you get the gender of the noun if it's a noun. So group is highlighted down at the bottom. Group algebraic is in red because it hasn't been, I guess, manually checked by a French-speaking person as a translation. To me, it looks like it's just slightly misspelled. But here's finally the entry in NLab, which is, pretty similar. There's not terribly many ways to define a group, but again, it goes on and talks about some categorical perspectives of a group, right? It's your special type of category. So why do we need something like this? I guess it can be a learning tool in many ways. So one of them is to help people learn math by making different resources available side by side. I know that I have tried to learn several things at different points in my life and just not understood one textbook, but then I go to another one and I'm like, oh, okay, finally, this makes sense to me. So kind of having these things more readily available, maybe with a description of what kind of resource it is, who it's targeted for, could help a learner figure out what's best for them and what kind of things they should be looking at if they want to understand a certain concept. I know there's also several courses in which professors are teaching both, formal theorem proving and natural language theorem proving simultaneously. I know there was an article a couple months ago in the New York Times called "AI is Coming for Mathematics Too," that kind of drew attention to a bilingual course that was in both Lean and English. I think that was taught by Heather Macbeth, who wrote, a nice kind of online textbook about Lean as well. Additionally to being a learning tool, it's an organizational tool. So very soon we're hoping to kind of incorporate other libraries of formal math to link them up to the same kind of table, right? So that you can find the same math concepts in different libraries if you're working in different languages, or just kind of trying to see what's out there. I guess the main kind of goal with that is to provide alignments between the languages and the libraries. So the concept of alignments is reasonably simple, right? You're just looking for the same thing in different places, right? This can apply to concepts and to theorems, and in some ways for theorems or rather proofs, the problem is maybe even disambiguating, right? Figuring out what proof is really different from each other, because you can say, oh, I've proved this, maybe there's only one way, but you use a slightly different lemma. But there's many different, I guess, problems within the umbrella of alignments. So currently the alignments are provided by a mapping to Wikidata. So this is a purely syntactic thing. We have the names of a concept, we format it in a way that Wikidata likes, and then we ask it, okay, do you have this concept in your database? If so, what's its number? And then we kind of match up all the things that have the same Wikidata ID. So this is, not a perfect method because, first of all, some things are not in Wikidata, some things are spelled slightly differently. If you get a plural somewhere, then you're going to have a problem. Often you end up with disambiguation pages if you're just directly asking Wikidata, oh, do you have group in your database? And then because group, as we all know, is a word in English and a very specific mathematical term, more general dictionaries and databases and things like that tend to kind of try to get it all. So if you just search directly for group, Wikidata will give you a disambiguation page. So there's kind of a way to get around this by asking for, maybe something that's a subclass of a math concept, but again, the semantic information in Wikidata is not perfect. Another way to do this is to steal from Wikipedia page names. They have a naming convention where they have a parenthetical with the subject after the title. I'm sure you've all seen it. So if you search group _ parentheses mathematics instead of just group, you'll get the thing that you're looking for. Right here are the problems with the method. So the next kind of step in providing these alignments, right, instead of just using the syntactic data from the names of concepts that we have and maybe any possible mappings between names and concepts in formal libraries, is to take advantage of knowledge graphs of formal math to kind of find connections between concepts. So Stefani has a talk about this kind of process on Wednesday, which should be very exciting. So essentially, math libraries are connected with very rich information. You can use this to kind of see, okay, if one concept is spelled slightly differently than another in a different library, and you're having a problem mapping it directly to Wikidata, if we have some initial mappings from one where we're used to the spelling or something, then we can bring that into MathGloss and kind of make it available to everybody without having to look at a very complicated knowledge graph that kind of incorporates the construction of statements of theorems and things like that. So there is a second version of MathGloss, kind of for category theory, called CatGloss. The sources involved in it are Wikidata again. It's made using the same process of mapping those names of concepts to just Wikidata and then collecting them, adding them all together. It also contains definitions from Emily Reel's book, Category Theory and Context, from Robert Goldblatt's Topoi book, which is slightly broken for reasons that we'll talk about in a minute, and definitions from Tom Leinster's Basic Category Theory, and finally the NLab again. So the reason that Topoi is broken is because this is kind of what we're working with. It's a little bit difficult to see, but there's lots of underscores in different places for different reasons, right? So the heuristic that is easy to use to get concepts out of a book with a LaTeX source is to just kind of look for the definition environments and maybe look for the italicized or the bolded or the emphasized words, depending on the author's choice of convention. So then in this case, right, so what we only had was a PDF. So there's no like LaTeX source available for the Topoi book. So what we had to do was use NuGet, which is Facebook's machine learning model for getting text out of PDFs. And it's for scientific research papers specifically, so it's actually pretty good at reading like mathematical formulas and translating them into LaTeX, right? So you can see that it gets the LaTeX formatting pretty well, but that includes underscores. So since the formatting convention that he used in the book was to italicize definitions, some of them are not preceded by the word definition and called out in a separate paragraph. Some of the definitions just kind of exist like in the middle of text. Also like examples or just headers are italicized as well. It can make it really difficult to kind of pick out the definitions, even if we have an index, which we do. So that was kind of the heuristic that we used to get the definitions from this book so far, but it's not perfect. It's far from perfect, in fact, especially because also NuGet can miss many, many pages of documents with lots of math notation, because it will just find a problem in converting the LaTeX and just decide I'm not coping and then skip the entire page. So yes, so we have another kind of option for picking out definitions from a source like this, and that is just kind of the process of definition extraction, right? Which is the name for the problem of asking a computer, a machine learning model, a neural network, an LLM to read some text and say, okay, where are the definitions in this text? So for a class project in the winter, my classmate Ryan Hathaway and I fine-tuned a pre-trained BERT model to pick out whether a sentence is definitional or not. So we had a couple corpora that we annotated, including sentences from the Chicago notes, because those were very highly definition dense, shall we say, and then a very definition non-dense, definition sparse source, the abstracts of theory and applications of categories, which was at one point supposed to be a MathGloss source before we kind of pivoted to more undergraduate and not research level mathematics. And so this does reasonably well, picking out definitions from other corpora, specifically like Wolfram MathWorld. That was another data set that we had access to. So it could be, we could use it to kind of extend to these textbooks and try to pick out the definitions from there, potentially combining this with just searching for keywords with the index on certain pages and just kind of make the process a little bit easier. So it doesn't yet, this model that we trained doesn't identify the term being defined, but again, when paired with an index, this is not terribly difficult. And moreover, if we have definitional sentences, LLMs seem to be pretty good at picking out which term is actually being defined by this whole sentence. So yeah, there's many, I guess, avenues for this to take, and there's lots to explore. Yeah, that's all I have. So thank you very much.
Thank you.